Hello, apa kabar semuanya? My name is Vincent, and currently I'm going to talk about doing the competitor analysis as a part of our tutorial, Basic Python for Data Analytics Stocks Prediction. So in this case, what we want to do is that we want to see how a certain company performs in relative with its competitors. So can we predict, maybe if there's a correlation among two different companies, can we predict one stock given the performance of the stocks of its competitors, because it's kind of similar industry, right? So can we do that? Well, in order to find out, you can type along with me, and you can see and I'm going to walk you through one by one. Alright. So first of all is that we want to get a new data that including 5 different companies: Apple, GE, Google, IBM, and Microsoft, big technology companies. And how we do that is that we will use the data reader, as we have learned in lesson number 1, loading Yahoo Finance dataset. So we can just copy paste this one, and go down, go back to our columns, and paste it. So you have DF, web data reader, and so on. And afterwards, maybe I can change this to so DF DataFrame competitors. Alright? But instead of just Apple, what I want to have is this company. So I just copy and paste it. And wrap that with open and close brackets. So basically, it mentions the competitors that this acts as a list. It's of one object, and this object has 5 different tags or strings in computer science term. Okay? And afterwards, I want to see what the result of this DF form. So I just run it. Oh, it doesn't give me anything. In fact, it says that I have dimensions 6 and 1771, and we have 5. So the problem now is that because we have 3 dimensions, so we have 6 companies, we have 5 minor axes, which is open, adjusted, whatever, and we have 1771 rows. How do you explain it in 2-dimensional tables? There's no way. It is 3-dimensional. That's why it doesn't show it. Alright? So the thing that we need to do now is that we need to extract one column or series. So what I do here is that I open close brackets and put and check the close. So basically it just highlights the executive close, and voila, there you go. You have Apple, GE, Google, IBM, MSCP from 2010 until the current date. So quite neat. It's updated. And you can change it with whatever, for example, like KO, and then run it again. And KO, if I'm not wrong, is a Coca-Cola, but you can see it too. So you can just do it with many different companies and then use it for analysis. Alright? So this is like to NSFD, and I put 10. I only want to have 5 data, so we see the format. Alright? Then afterwards, if you want to see the dimension, then call the shape. Simple, 1 rows and 5 columns. Then afterwards, you want to get the percentage change of this company. So what I do is that I go here in a variable that's called the returns of the competitor, and I do df dot basically change. Then I can run it, no problem, and I can find the correlations. And it's very simple. This is very simple. Just call correlations of the returns, call, and no issue. And I want to see what this is all about, so just call. Notice here that now you see the correlation. So you see like 2 dimensionals and 5 columns for each dimension, the row and the columns. So this directly show me that, oh, these are the correlations with the Apple and Apple, GE and Apple, Google and Apple, and so on. But of course, this is not intuitive yet, so let's do something with it. But first of all, let's create a scatter plot. So to do a scatter plot, it's PLT and scatter. And what do we want to see? We want to see the returns of, let's say, Apple and GE. So we want to see rescom, APL, and rescom GE. So basically, it will give a scatter plot. But of course, it's not intuitive enough, so let's define the example. Example is Apple, and just APL, and variable is GP. So if you run this again, you can see G here and F as well. So quite neat, but doesn't say much yet. So what we do now is that how about if we create another one scatter plot, like a matrix of scatter plots. So we can do that by scatter matrix. Alright. Then what we want to do is that we want to put in the data, so that's comp, the returns, and what we want to do is we want to fix size, so that we make it easier to see. Then we run it. Control Enter for quick running. You will see a bunch of these text, and you will see the charts. So the charts here, you can see that now there's a sort of like histogram and the scatter matrix. So the histogram will show you that, oh, this is the histogram of Apple instead of G on. But it's not intuitive enough, and we want to delete this print out, which doesn't make sense. To delete this print out is very simple. Just add dot comma, semicolon, I believe that's what they say, and just run it again. And you will not see, you should not see printouts anymore. So it's done. But maybe you can make this more intuitive. So what can we do? In the help, you can see here that there's a diagonal histogram. So by default, it's a histogram, but you can choose KDE, for example. So KDE stands for kernel distribution estimation, and it gives you a very nice looking sort of normal distribution charts. But what you can see here, you can see that the more it's leaning to the right, especially the majority here, is that you can see that the larger proportion is actually bearing positive returns than negative returns. So if you compare Apple and Google, Apple have more positive returns than GE, and definitely more than Google. But compared to IBM, not so much. IBM is have more positive returns if you compare to the history. But Microsoft, not so much. Okay, so we can do it here and change the companies and see the different companies at the same time, which is cool, right? Then afterwards, we want to create a heat map of the correlations so that it's more easy. So what we do is that we use CRT unshow. The CRT unshow is image show, and afterwards we can use CMap, and I think if I'm not wrong, it's parts. And we should give the data here as score. And if we try and run this is what we get. But you might ask, what the heck is happening with this white color? Well, it's because that for the correlations, of course, Apple and Apple have correlations of 1, whereas the rest is not so much 1. So what we want to do is that we want to make sure that Apple and Apple maybe like does not have much weightage in this chart, so that we can see the other values not superior except Apple and Apple. Okay, because you're comparing the same thing. So of course correlation is 1. So what we do here, there is a method, there's an, what do you call it? There's an argument called interpolation. So interpolation equal to none. So we do it again and give you a very nice looking chart. Okay, so just white like that. So it kind of separates this white compared to other color. Now the next thing is that I want to create a label of this so that I can see what this data is for. Is 0 to 4. What the heck is 0 to 4? So one thing that we want to show is color bar. So it gives you a nice looking color bar of this. Another one that we want to show is the ticks. Ticks. Okay, and these ticks will be cut from the correlation column. So it will be range of length of the range length of the core. So given that how many length of the core is this gives me core columns. This gives me the columns of the core. So if I type on this, you can see that now we change the 0, 1, 2, 3, 4 into a good label. do the same thing with the one ticks. Just copy paste, copy paste, then do the same thing with one ticks, and maybe to eliminate the print out, and column everything, and that's it. So you got a very nice looking bar chart. So from here, So from here, what you can do is that you can see that IBM and GE sort of have quite high correlation with each other. So we can see and consult the table, and there it is. IBM and GE is 0.53. So maybe next time you can put a consideration on IBM stock if GE stock is performing really well. Alright? Or maybe there's some news about GE stock that's very good. So maybe you will carry on for IBM. Of course, don't take it for granted. You still need to do your research, whether it's really such thing or not, or is it just coincidental, obviously. Okay. So afterwards, we want to do stocks mean and risk calculation. So based on the correlations and everything, and the returns, can we like compare all of these stocks in a very nice chart. So this one, maybe to save time, you can just take a look. I'm going to explain the line one by one. You can just copy paste this, get from my GitHub, and then run it on your own and change the companies along the way. So what this chart will give you is that you will create a scatter plot. So this just will create a scatter plot of mean and standard deviation. And afterwards, we fill in the scatter plot using our own defined methods. So we want to find returns and risk. So returns is the mean, risk is standard deviation. Okay. And afterwards, then we want to set off the dots. We want to annotate the dots. So you can see this annotate is this yellow color here, yellow color box, B box. Okay, B box here, and then the text coordinates. And finally, we want to determine the error plots. So basically, that's it. And the next time you see at this chart, then you can see that for IBM, I want to make sure that my IBM is quite nice expected return given the risk. So maybe the risk occurs in IBM, or maybe if you're not, then maybe Apple, Google will do. So that is how you use this chart. Then simply put, it's quite simple to analyze this. For example, if suddenly this is not enough, maybe I can change into one more Samsung. I don't know, Samsung thing. So label, you can find it like that. Samsung stocks. What is Samsung? Yahoo Finance stocks. Okay, whatever. For example, Amazon. So Amazon, then we can just do Amazon here, and then just run it, and then run the same thing with Amazon with the rest. So you see Amazon is appeared here, and just run it, and run it. So the next thing that you will see is that all the charts will have Amazon, and you see all the Amazon will have Amazon, and you can see, wow, Amazon NG is good. Then you can see that Amazon is at a high tier of compared to the other stocks, so you can see why it is, and you can just add on companies or delete companies along the way and understand stocks much better. With that, I would like to close this tutorial. Next one is we are going to predict the stock price. It's going to be a very interesting one. So sampai jumpa, ketemu lagi di lesson selanjutnya. See you in the next lesson. Bye bye.